I'm going to delete this code here. And here we now don't have anything called a hash table. We don't have anything yet. Everything's deleted. Now let's create this thing called array, an array of list. So to create an array, we know that a list is like that. We define a list like that. So an array of list is something like that. Product um, list array. Okay, let's just define uh, the size of the array will be set to 1000 or 24. This is a random value. I just choose it like that. So this is a static array. So this array will be created when the program starts, and it contains of lists. So a list of lists. It is an array of lists. So I'm gonna call it array of lists. We have an array of lists here. So it contains 120, 1024. I'm gonna make it 50 to just make it doesn't make that much sense. So I'm gonna say define another variable. I'm gonna say the size of the array, and the size will be 50. Okay. Now we want to add a new product inside this array. How do we do that? So as we said, we first create a product, or let's say I'm just going to create a product, but we don't need to for now. Yes. So an array of lists. I'm gonna add an S. So this is the new, we're trying to represent the new data structure where we have an array of lists, and when you need to add a new element in the array, a hash function will get to decide to which list you want to add it. So we have this array of lists. Then the next thing is what? We want to add a new product, and I'm going to declare a variable, or let's just make it simple. I'm going to declare a variable like that and call it um, uh, prod, okay, and set it to null. And what I want to do now is to create a new product, and call the new product function. The new product function receive milk and let's say 33 or 35. Okay, it's time to add it to this array of deeds, which is our actual hash tables. This is the hash table. The array of list is the hash table actually. So we need to have a function to decide to which list we want to add this new product item. For that, we have these things. Um, um, I'm gonna call the function like compute keys or determine. parent, let's say determine list index, okay? Or compute, I'm gonna say compute list index. Maybe there is another name. You can say in the chat what names is more understandable. So this function named compute list index will only receive the new product name as value and some other parameter. I'm going to say y later. So the list size, it should receive the list size. So it's going to compute the list index and return it. And this one, I'm going to declare a variable parent list index. So this function decide to which list we want to add. Then next, we know where is the list. We call the function add or update. We already know the index of the list, so we pass in the array of lists. Oh, it's starting to get long. The names of the variable are very lengthy. I'm gonna break it into multiple lines. So this add or update function receives, let's say, a list, a pointer to a list. So the product list, and also receive, let's say, the name of the product name, and what else? The price, product price. So these are the three parameters. Okay, someone asked the questions. Is that the hash function? Uh, and the question also is, why does it take the size and why does it take the price as well? Okay, so let's start from here. We have this list of array, this array of lists, and it contains the reference to a lot of lists. And the question is now, I'm going to delete all this and make things, I think it's better. Okay, we have this array of lists, and we want to add a product into this array of lists. So our hash table. So we need to find a way to determine to which list we want to add. We want to add the new element. So we have to first determine the index of the parent list. So the hash function, it will be deciding where to add the key, the new elements. So I'm gonna say, I'm going to declare a function named compute list, compute index, okay? And this compute index is what I can call a hash function. And what we want to add, we say, okay, we want to add an element in this hash array, meaning this array of lists, and we want to know to which element, to which list, and it will return the index. So we pass in the size. We need to pass in the size of the array because this computer index or this hash function needs to know what is the maximum index available, so we don't get out of range. This function is not created yet, but this is it for now. I'm going to declare a variable named index, for example, list index. I'm going to declare like that. So this function will say, okay, for any key that has the value milk, you can add it at this index I'm going to return. Then, okay, we say, yes, we know now to which list we're going to add it. Then we can get the list. So we have the array of lists. We pass in the list index. So we have the list. We know the index of the list. And now we can add this milk thing in the list. So array of lists return list index will return the list, the the list, and now we want to add this thing called milk, uh, the milk product in the list. So since we have the list, we know the position, then we call the add or update product on that list, and we access this list through the array. So I'm going to take that and copy it here. So this is the list. We already know how to add an element to a list. So we need to pass in the address of that list in the array, the name of the product as what we did before. Before we only had one list, but this time we have an array of lists and we're deciding to which list we want to add a particular product with a particular name. And the price will be um, set to 50. And this is it. Basically, this is how we add things um, or a new node in a hash, let's say in a hash array. You decide. Now, this function called compute index, we need to create it somewhere. And we also need to test this function, how it works. And we also have to change a bit the way the search product by names works. Someone sent a message. So now this is the hash table, the function return and update the hash table. So basically, this thing called array of lists is our hash table. And it contains a list, and we have a compute index function that decide uh, which elements in the list. And since the elements in the array, let's say, since the elements of the array or list, then we can call the list utility functions on those elements. So that's why we don't have to add some other special things. There are lists and that's it. The only thing that changed is now we have a lot more than one list, and we we have this function that decide to which list to look for, in which list to look the new element or to add the new element. Now let's add this thing called compute index. The naming can change. You can have different names for the same things, but the underlying principles are always the same. So this exercise, we only have names that make sense. So here I'm going to say um, the index, instead of saying it is an int, we're just going to say unsigned int, unsigned, unsigned long int. So unsigned because, or I can say unsigned int. I think that's it. Unsigned int because index are never negative numbers. So we have this thing called compute index. Then we pass in a string, let's say the name of the product. The name can be considered as the key. The key is the thing that identify an element from other elements. So the name in this example is the key. And we pass in the unsigned int size. So the size of the list of the hash array, which is basically the array of list. Then next, I'm going to create a file for this function called compute index. Then include all these headers, files, and what else? We have unsigned in compute index. Then we pass in the name of the product, which is the key for our list. And then we pass in the size of the list or of the hash array.